This video will be 6.1. I can solve addition and subtraction equations. And before we start, it's important to understand the addition property of equality and the subtraction property of equality. The addition property of equality says that if I add the same number to both sides of an equation, it will stay equal. So let's write that down. So the addition property of equality, if you add the same value to both sides of an equation, the equation will stay true. So that means if I have, let's say I have just 3 equals 3. This is an equation, we have an equal sign, and both sides are equal. If I add 4 to this side and to this side, my equation still stays true because 7 equals 7. If I only add a 4 to one side, is the equation still true? It wouldn't be, because this side is 7 and this side is 3, and they're not actually equal. And then we talk about the subtraction property of equality. The subtraction property of equality is almost the same thing. The subtraction property of equality states that if you subtract the same value from both sides, the equation remains true. If you subtract the same value from both sides of an equation, the equation remains true. So same type of deal. If I say 10 equals 10, which is true, if I subtract 3 from this side and 3 from this side, I get 7 equals 7. So the equation is still true if I subtract the same value from both sides of the equal sign. We're going to use this when we solve addition and subtraction equations. So for my first equation, for our first example, let's do x plus 7 equals 14. So you always have to do the inverse operation to undo what's being done to the variable. So actually, I should say this before. When we solve equations, I'm going to write this down over here, our goal is always to get the variable by itself. To get the variable alone, and then we have to use the inverse operation to get the variable by itself. So we're going to talk about inverse operations. The inverse of addition is subtraction, and the inverse of subtraction is addition. These are two really important things we're going to have to use to solve any addition and subtraction equations. So if we go back to our first example, example 1, x plus 7 equals 14, we're going to draw a line down the equal sign just to remind us that whatever we do on this half, we have to do on this half for our equation to remain true. And then we want to get the variable by itself. So if our goal is to get the x alone, we have to undo what's being done to the variable. And what's being done is they're adding 7. So what's the opposite of adding 7? Subtracting 7 from, and if I do it on this side, I have to do it on this side. And then I'm going to balance my equation and see what's left over. So 7 minus 7 is 0. So all I have left on the left side is x plus 0, but I don't need to write the plus 0. And then 14 minus 7 is 7. So I have x equals 7. And then I should check my work. So to check my work, I'm going to plug 7 in here for x and see if I get 14. If I do get 14, I did it correctly. If I don't get 14, I know I did something wrong and I have to check my work and go back. So if I plug 7 into here, I get 7 plus 7 equals 14. And I'm going to see if this is true. Let's simplify this side. 7 plus 7 is 14. And 14 equals 14, that's true, so we did this one correctly. X must be 7. For example 2, let's do y minus 3 equals 9. And we'll start by drawing a line down the equal sign. And we always want to do the inverse of what's being done to the variable. So if we want to get y by itself, and they did a y minus 3, we want to do the opposite and do y plus 3. Negative 3 plus 3 is 0, so I have y equals 9 plus 3 is 12. Then I should check my work, so I'm going to replace the y with a 12, and see is 12 minus 3, 9? 12 minus 3 is 9. Does 9 equal 9? Yes, it does. Okay, for example 3, let's do b minus 1.4 equals 9.6. And we want to make sure we don't get intimidated by decimals because it's going to be the exact same procedure as before. But I want to talk about another way to do a subtraction problem. So here we had a subtraction equation. I said the opposite of subtracting 3 was adding 3. There's another way we can think about it. Usually when we subtract, we change the sign in the one behind. Let's do that here. Now, what's the opposite of a negative 1.4? The opposite of negative 1.4 is positive 1.4, so I need to add that to this side and to this side because my goal is to get b by itself, and negative 1.4 plus 1.4 is 0. So I have b plus 0, which is what I want, equals 11. And that's just another way to think about a subtraction equation. So I'm going to check my work. I'm going to say 11 minus 1.4, is that 9.6? And I'll simplify the left side. 11 minus 1.4 is 9.6. So the equation is true. So we did that one correctly. For example 4, let's do 13 equals 4 plus q. So this one's written a little bit differently in a different order, but we're going to solve it the same way. So I'm going to start by drawing a line down the equal sign. My goal is to get the q by itself. And q is being added to 4, so I want to do the opposite, and I want to subtract 4. If I subtract 4 on this side, I have to subtract 4 on this side. 4 minus 4 is 0, so I just have a q on the right side. 13 minus 4 is 9, so I have 9 equals q. And then I'm going to check my work. So 13 equals 4 plus 9. Let's see if that's true. 4 plus 9 is 13, so I must have done that one correctly as well.